from their desk or from their house. We hope that you enjoy the program over the next 2 days. And for those of us here in person, it's great to see so many of you again and have the opportunity to catch up again in person. So we'll continue with a grouping from the courts. The Right Honourable Beverly McLaughlin, former Chief Justice of Canada. The Honourable John Laskin of the Federal Court of Appeal. The Honourable Glenys McVeigh of the Federal Court. The Honourable Richard Southcott of the Federal Court. The Honourable Mary Saunders of the British Columbia Court of Appeal. And Madam Prothonotary Alexandra Steele of the Federal Court. From our sister associations and partnering organizations, Tanya Clark, President of the Chartered Institute of Trademark Attorneys from London. Lee Davies, Chief Executive of the Chartered Institute of Patent Attorneys, also from London. Enrique Diaz, Treasurer of the Inter-American Association of Intellectual Property from Mexico City. Isabel Chabot, Assistant Secretary General of the Bureau International Association for the Protection of Intellectual Property, or as we most commonly refer to it, AIPPI. Grégoire Bisson, Director of the Hague Registry, Brands and Design Sector, WIPO, in Geneva, and Alfred Macchione, President of the Canadian National Group of AIPPI. And please join me in giving the committee a round of applause for a job well done. So, Paul, I'll turn the podium over to you.
Thank you so much, Grant. Good morning and welcome. Thank you so much for coming today. You have so many choices for the programs that you attend, and we are so thankful that you have chosen the IPIC annual meeting. And now I am so excited about our keynote speaker. Our keynote speaker has always been curious as to how technology works. That curiosity, combined with entrepreneurial passion, has led him to create numerous companies and innovations. As a cloud pioneer, which we take for granted now, but as a cloud pioneer, he participated in the early launch of Google AdWords. He pioneered software for industries such as e-health, real estate, mortgage banking, private and public capital markets. His work has been used by small businesses, multinationals, governments around the world. Through observing how billions of transactions in diverse industries and millions of users interact across borders with regard to global cultures, he has envisioned what the future would likely be in the early days of blockchain while working in the hubs of Silicon Valley and Boston. With BlockSearch blockchain, Tim Vasko is blazing another new trail for technology, which makes blockchain and smart contracts broadly accessible. Tim Vasko, thank you for coming because we are so looking forward to your talk. One of the things that we're quite interested in is that your thoughts on how you believe that we're entering a fundamental shift through the economics and trust through the blockchain that will impact every person. Tim Vasko has been a popular keynote speaker for a number of recent events, including Startup Canada's Global Entrepreneur Challenge. He recently met with Prime Minister Justin Trudeau to discuss Canada's role and technology roadmap for the future. Tim Vasko was recently named one of the top 10 leaders to watch by Entrepreneur magazine. Thank you so much, Tim, for coming. We are absolutely honored, and I'm excited to learn what the future is going to look like for us. Thank you.
Wow. Not sure I can live up to all of that. But I'd like to first say I'm honored to be here with such a group that has the idea business and takes control of ideas and helps people. And that's what we're going to talk about today. But as I do that, I want to ask you all to participate with me a little bit. And so I hope you don't mind, but what I'd like you to do is kind of answer a question for me. If you had one word that you could say is the biggest challenge today, the biggest thing you can think of that challenges our future, one word, what would it be? Email. That's a good one. That's old tech. One word, come on. You guys do words for a living. Knowledge. Security. Environment. AI. Fear. Uncertainty. These are all great words. But I hope that we can bring all those together when I talk to you today. There's a great book. I don't know how many people might have read this book. It was called Einstein's Dreams. It was written by Alan Lightman. And in that book, there's a little sentence that says, a person who cannot imagine the future is a person who cannot contemplate the results of his actions. So let's think about that as we're talking about what technology is and what you guys do for a living, what you do in your careers, what you've done and trained for. Now, I want to ask you to do another thing for me. Will every woman in the audience please raise their hand? And keep them up. I promise it won't take long. And it's good exercise anyway. Okay, now, I want you to look around, everybody whose hand is not up. Okay? Now, everybody's looked, okay? Now, I want to do another thing. Everybody in the audience whose hand isn't up and has a daughter, please raise your hand. Now look around. Okay? So today, you can put your hands down. Today is the International Day of the Girl. It was founded in 2012 by the United Nations. And when we start thinking about profound shifts, the first thing we need to think about is what's behind those profound shifts. And although I appreciate everybody's comments, what makes all of those comments, all those words you came up with, meaningful? It's people. And people are growing exponentially in the world. And nowhere more are they growing or are they younger than in Africa. 60% of the African population is under the age of 25. There's 1 billion people that are under the age of 25 in Africa. Which means that by 2035, it will be the largest workforce in the world. Okay, 2035. Now I'm looking around the room, and most of us, if we exercise, eat right, stay healthy, will be alive in 2035. That's 17 years from now, I think, if my math is correct. Okay? So let's do another little thing here together. Stop for a minute and let's think, what does 17 years from now look like? Let's imagine that future. And I'm not talking about the mythical future. I'm talking about the future that we're all going to live. We're going to live until then, and we're going to live through the next 17 years, barring any unforeseen circumstance. So just take a moment and imagine your future in a world where the largest workforce is on the other side of the world. What's your job going to be like? How will your job get done? How many people think that 17 years from now, what you did yesterday before you came here, what you'll do tomorrow or the next day when you go back to your office, how many people think that you'll use the same technology? How many people think your job will be done the same way? How many people think that the people who are doing your job, including you, will be doing it the same way? How many people think we'll be using email? How many people think we'll be using email? That's a really good question. Nobody. I agree. But the problem with people is this concept of we need to know who they are, don't we? So how many people traveled here to Vancouver? Look at this. At least half of the room. Now, how many people have some form of identity in their pocket? There's only a few of you who have no identity, which is good. It's a little concerning considering the crowd I'm with, but on the other side of the world, most of us watched this summer, a lot of us watched this Thai cave rescue. The kids were out there. It was amazing. It was heroic. It was fascinating. And at the end, what we found out is these kids didn't have an identity. Nobody even knew they existed except them. Right? If you don't have an identity, there's still 400,000 people in Thailand that don't have a state. If you don't have an identity, you guys are a lot of intellectual property attorneys. Can you own property? Any property. You can have an idea, but can you own an idea? So the question being, our largest workforce that doesn't have an identity, can they own ideas? They can have them. On our side of the world, our first world problems are a little different, aren't they? Data and identity. How many people care if your identity is stolen? Really? I mean, really, few people don't care about that either, but those are the same people that don't have an identity in this room. We're going to talk about that too, right? How many people care about intellectual property? There, the whole room's hands went up. Good. And that requires authentication. But, you know, the father of the modern computer said this. He said, sometimes it's the people no one can imagine anything of who do the things no one can imagine. How many ideas are out there in that world that you need to protect, that you need to help to protect, and how will you do it? That's really the challenge, isn't it? Isn't that really the challenge? Isn't that what you face every day, is how you do that? And that is, in fact, the three insights, the three real insights from blockchain. This first insight being that idea of trust. So the blockchain is broken into three layers. The protocol, which is the code, the geeky stuff. The network, which is also quite geeky. And the networks that we know of are like Amazon, Microsoft Azure, Google. We know these networks, these cloud services, these large organizations that provide this compute power. Oracle, everybody, IBM, they've all got clouds, right? That's the network. That's how this stuff gets done. And all those clouds are connected to what we call the application layer. How many people in the room have a mobile phone, a mobile device with an app on it? At least one, everybody, right? Okay, so that's the connection. That's the application layer. And so, I want to go back here. So when we take trust, it's protocol plus the process, the way that that's written, that's the underpinning fabric of the blockchain. The truth is this concept and this idea of distributing data, of creating data that can be protected, that can be kept private, that can be owned by the individual that created the data. And finally, the transparency, this idea of transparency, is access and authentication. Access and authentication. How can you own anything? How can you participate in anything if you don't have access, if you're not included? You can't. So, in 2001, on our side of the world, we started seeing this breakdown of central authority. Not that this hasn't happened before, because it has, and we can go back historically and look at it. But in 2001, it was pretty shocking when we heard about organizations like Finova, who was the largest fraud in history, and they held that position for just about 6 months before Enron came along. Okay? So it was this breakdown of of ethics and this breakdown of control that started in 2001. What was happening in that big world out there besides what we were all seeing happen here? In Africa, in 2001, about 30% of the people started getting mobile devices. Okay? By 2015, the African population, and this applies to India as well, by the way, and China, but we're talking about Africa. By 2015, there were the same number of mobile devices in Africa as there were in North America. 80% of those devices were being used for text messaging, 53% for taking pictures, capturing the world around them, and 30%, 33% actually, I think, for making payments. So while technology was being distributed globally on the other side of the world, what was happening on our side of the world 7 years later? Anybody remember this? How many people remember what happened in 2008? Because I sure do. It was awful. The meltdown began, and it happened fast. And who would have ever thought that firms, some of them hundreds of years old, would just collapse under this failure of centralized authority? That was 2008. Well, who would have thought about that? Did Satoshi Nakamoto think about that? How many people know who Satoshi Nakamoto is? There's 5 people in the room who know who he is. None of the rest of the world knows who he is, so I want to talk to you guys after that. Because it's a pseudonym for the guy who wrote the white paper on Bitcoin. Okay? Maybe it's a real person. We don't really know. But you know what? It wasn't Bitcoin. It was not Bitcoin that came up with this concept of the social currency or the social dollar. It was Bitcoin, and it was Nakamoto's insight that created this concept of how to put all the pieces together that had been invented. But the real inventors of this technology, this has been built over decades. And in 1998, a gentleman by the name of Nicholas Szabo, a Hungarian legal and computer scholar, first came up with BitGold and the smart contract. Mudgy out of budget. How many people know what that means? There's one Hungarian in the room. And the reason I bring that up is just for my dad, because he would have loved the fact that the guy's Hungarian. But the point is that Szabo saw this in 1998. And of course, he saw that there was a way to create this kind of legal structure that didn't require authority and started building that. But he wasn't the only one. Muhammad Yunus said a charity dollar has only one life. A social business dollar can be invested over and over again. Who knows who Muhammad Yunus is? There's a few people. Muhammad Yunus is a Nobel Prize-winning scholar, a founder of Grameen Bank, which literally means the rural bank. And in 1974, he walked out of his academic offices and looked at people on the street and said, I can help do something here. And he lent 42 families $27. $1,134 was his risk. That was his risk capital. The banks would not support Yunus's vision. Today, Grameen has 2,600 branches globally. They have 9 million borrowers. They have a 99.6% payback rate. And 97% of the borrowers are women. In Africa, 60% of that billion people under the age of 25 are women. Can we start seeing some trends here? So I love this quote. which says in the future the question will not be, are people creditworthy, but are banks people-worthy? Are they? Do we need banks? Maybe the question isn't so much, do we need banks? Bill Gates once said, banks are not necessary, but banking is. So maybe the question isn't so much, do we need banks, but the question is, who has the property? How do we hold that property? What is that property? How do we own it? Maybe that's more the question, isn't it? Because isn't property value? And aren't we really talking about value transfer? So the global potential for micro business loans is $1 billion, or $250 billion, to about 1 billion people. That's $250 a person. My question for you is this. That's that same billion. The billion keeps coming up, right? 1 billion people under the age of 25. 1 billion people who don't have an identity. 1 billion people who want to borrow some money. Right? How are you going to help that 1 billion people start participating in the intellectual economy? Well, one of the ways is going to be with this technology. So when we look at this, it doesn't really become all that surprising then that $1 trillion or more has been invested in fintech and blockchain technologies already. Look at the curve. It's astounding. It also doesn't become surprising that in 2017, the third largest market cap, just behind the U.S. debt and the S&P 500, was cryptocurrency. In 300 days, it climbed up to be the third largest market cap in the world. So what I'm going to ask you is, how are you going to participate in this idea of trust, or what I would call intellectual inclusion? Because if there's going to be financial inclusion, doesn't that, in essence, mean people need to own businesses? And are businesses not property? And are the ideas that drive those businesses not property? And are the ideas of how we might do something in a country where no one else can imagine how to do it, and somebody's actually working there, maybe they've got an idea, and it's unique, and it can help. That's what I think intellectual inclusion means. It means providing that access. And do they have that access? Do the people that we're talking about have that access? I already told you they do. So that's kind of my idea about ideas. The idea about ideas is that when we start codifying this, when we start removing these big barriers through things like blockchain, data, distribution, applications, networks, we start enabling people, and what happens is this brilliant thing called game theory. I'm sure many people are familiar with game theory. Game theory basically says, it talks about access to information. It talks about the equalization and the transparency of information and how decisions will be made. And it has this profound economic impact on what we do. So let's talk about this idea of game theory and this idea of what a genesis block is. A genesis block on the blockchain is the first block of a blockchain. And what it does is it takes and it combines all of this data into this block, and that's what it looks like. Can anybody tell me what that is? How many people can read that in the room? Come on, this is a smart room. Somebody can tell me what that is. What that says. Nobody. But it's there. That's the genesis block of Bitcoin. Okay? But you can't tell me what it is. Yet, it's there. It created true value, didn't it? And if you have the code to unravel that, and you could see it, you could unwind that Genesis block, then in fact, we've solved some serious problems, haven't we? Nobody, this is a brilliant room of people, nobody could tell me what that says. But if you have the code to unravel it, I'll bet you could. And if you dig a little deeper into that code, and you start reading the contracts, I'll bet you could say what they say. You can see what they say. And if you dig a little deeper and you saw how every step within that Genesis block was created, could you not see exactly how we got there? Think about what that does for the legal system. There's this little thing I heard about somewhere called discovery. It's right there. Think about what that does for figuring out what is the truth. Isn't that really what the court system's about? Aren't they trying to discover the truth? I wouldn't want that job, sitting on a bench. No thank you. No thank you. No thanks. Identity equals the ability to have property rights. Ideas are intellectual property, and the innovation of blockchain kind of comes down to this concept, which is now evolving into proof of stake or proof of authority. Currently, the blockchain is mined. Mining is all these supercomputers. You guys have probably heard about it, all the supercomputer things in Iceland consuming all the energy. Somebody's from Halifax. I think there's a big computer farm in Halifax, right? I think that Montreal or in Quebec, there's a big computer farm, and it's just consuming all this energy. That's not sustainable. It's absolutely not sustainable. What is sustainable is right now, I'm not using this, and it's sitting there, and it's probably, if Bell or Telus is on, connected to the internet, and it's got compute power. And we have billions of these things running around there. I was in Oracle's office talking to some of the head people, and they were selling me on their cloud. We're partners with Oracle. We're partners with Microsoft. And they said, Microsoft really came to the table and sponsored us to do this. And when Oracle asked me, would we go on their cloud, I said, sure. They said, we've got more compute power, or as much compute power as it would take to power the entire globe 3 times. I said, oh, well, then I'm bigger than you. And they said, what are you talking about? And I said, well, I got Microsoft too. So the point is distributed, right? There isn't going to be this concept of central authority anymore. There's going to be this concept of proof of stake. Can I prove that I have that identity? Can I prove I have a stake in this? Can I prove through that Genesis block of mine all the way through to what I'm trying to accomplish with my business or technology or intellectual property, what have you? Can I prove that that's mine? It's a fabric. Blockchain is a fabric, and it allows us to do that. And it's built around this concept of trust. And so by 2018, we now see all these ideas of trust coming out. Again, there's a Adams Seligman in 1995 wrote a book called The Problem with Trust. And he said as technology emerges, in 1995, as technology emerges, we're going to have this huge issue of trust. And then Francis Fukuyama, another political scientist, wrote that the enormous prosperity created by technology-driven capitalism serves as a human incubator for human dignity. Well, it really does, doesn't it? It really has come to that point. And it's evolving in very real ways. So Uber, Upwork, these are distributed platforms that rely on this idea of being able to work anywhere for anybody, and these guys are going to take care of your payment. They're going to validate your payment. They're going to get it to you. And guess what? If you don't do a good job, you're out. So they have the authority. But what happens next? This is very, very, very early visual, experiential way for us to see what blockchain's about to do. Because they have the authority. What happens when we take that authority and we distribute it into the code, into the protocols, into the smart contracts that are written, that you will write, that no longer are PDF forms shared by file manager or some signature thing like DocuSign through email. That's not how it's going to happen. And you're doing the work today. You're doing this work. How many people type still today on an IBM Selectric? Come on, somebody's got to have some old school in them. Nobody? How many people use a word processor? How many people save their work to the cloud? How many people write contracts? How many people write documents in the room? Come on, there's more than 3 people that write. I'm just kidding. Okay? What you're writing and what you're doing and what you're getting paid for is this idea of mutable trust. You're putting this truth in, especially this idea of truth and transparency to reach consensus. And I've had this amazing experience over the last 7 years in my own patent journey, and a great teacher and my patent attorney, Doug Thompson, who constantly tells me, nope, that's not going to work, when I got my first patent granted. And I learned a lot about the way this works and the way this actually transpires to create this idea of consensus. Yes, that is a unique idea. And yes, you can have a patent. And yes, you can own it. And I'm a really lucky guy to be able to own something. As I was walking over here, I was recalling my own experience of coming to Canada 20 years ago with my 2 older children. And we had been in Canada. We were coming down. I got a work visa from the university, or I got a work letter from the university. I needed to go get my work visa. So we parked our car on the Canadian border side down at the Peace Arch. We walked across the border. We stood there. They said, you have to enter Canada. I'm like, I'm already in Canada. They said, you have to enter Canada. I'm like, okay. So I left Canada, I went to the United States, walked around the building, stood there, and there was a family there that had 3 little kids and a suitcase. And I had these 2 little kids, 6 and 8, and I'm a single dad coming into Canada. And I stood there with my children, and I said, do you know what the difference between them and us is? Everything they have is in that suitcase. And on the other side of this, we have a house, we have a car, we have the same opportunity to walk across the border and come into this country. But we have a lot more to be thankful for on the other side. And it was a very profound moment, and I gained a Canadian identity. So I have 2. And I'm extremely blessed with that, but many people don't have that. And so when we think about this kind of data that we consume and the truth that's behind it, it's really important for us to understand what custodial natures are about the truth. I couldn't help but chuckle a bit when Google's president was up there trying to explain why they didn't disclose that 140 million people's data was compromised. And I don't even want to go with the other guy. That was a fascinating, just a fascinating testimony to watch. So what we've seen then is we've seen that not only does the financial system, did we outgrow that structure? I'm not saying it's bad. I'm saying we outgrew it. we've also now created so much data and so much technology power that we've outgrown the capacity for our current level of thinking to solve these significant problems we have. That's a paraphrase of what Einstein said. We're way beyond scraping data to put up credit scores and letting another 160, 170 million bits of people's data go missing. We're way beyond that. We cannot sustain the internet and technology with the systems we have. So what's happened now and what's emerging is this idea of IPFS. How many people know what IPFS means? It means interplanetary file system. And I just love that because we're prepping for conquering new worlds, guys. This is Star Trek stuff. This is cool. This is really cool. And I saw one of our guys, he did a demo of our IPFS system. It's in our labs right now. I'm like, that's so cool. And, you know, the closet geek, maybe not so closet geek, came out of me. And I'm just like, that rocks. That's how files are going to be shared. That's how we're going to do it, right? And it's here. This isn't imaginary. This is not imaginary. When we stand up a blockchain, we don't stand it up on Amazon. We don't stand it up on Microsoft Azure. We stand it up everywhere. And when we break these files down, like that Genesis block I showed you, you got to have the private key to unlock it. So the question really becomes, who gets the private key? And the answer is, you do. I do. We hold our own private keys. Now, there are going to be technical challenges around that, for sure. Like, what happens if I lose my private key? Good question. How many people have heard about, I had 100,000 Bitcoin and they're gone, I lost my private key. The dog ate my homework. I mean, whatever. That's not, okay, sorry. You know, you just lost $20 million. Oops. This idea of data then leads us into this kind of concept of transparency. Transparency doesn't mean that everything we do, the emperor has no clothes, we're running around naked, we're showing off everything. That's not what it means. That's just the fact that we have authentication and access and we can see what happened. If we have permission. So the blockchain looks like this when it's properly set up. This is the blockchain. There's a public blockchain and there's a private blockchain. There's permissions and there's permissionless. So a public blockchain, anyone can see. It's permissionless. Can anyone do a Google search? For sure. But can anyone look at the code, the source code that created the Google search? Of course not. Except for Google. So you start getting the concept of when you're forming your intellectual property, you start thinking about, well, what are these four quadrants that we're going to have? Who can see what? At what level am I going to authenticate this? At what level does the private key enable me to write the protocol so that I can make sure when I build that block, I can see these elements or I can distribute these elements in a way that it makes the most sense for what I'm doing. There's a lot of thinking that has to go into what you do every single day, or what I do every single day. We have to think about the way that we create, that we can allow for updates, because things change, processes change, that we write and that we read things, what's happening in that big circle around the blockchain. Those are the elements that you have to start thinking about in order to embrace the new technologies that were here. Now, some of you, like the guys, the 5 people who don't have any identity in the room, there's good reasons not to have identity sometimes, right? The guy on I guess it would be your right, maybe he didn't want his identity out there when he wrote that book because he went into hiding, right? And clearly, nobody knows who the author, who the real author, authenticated author was of Bitcoin. And the guy in the middle is another Hungarian called Anonymous. Very famous in Hungary for being the guy who wrote all about Hungarians, but he's like, at one me, right? But once we know whether it's the person or not, we know what authentication is. So let's think about this. And I always like to ask this. How many people in the room like really good food? Like really good food. Okay? And there's a few people who like bad food that I saw. And how many people in the room then, even the people that like bad food, like to eat? And there's always a few people that don't eat, and that I still want to figure that out. But there are 2.5 billion people. We talked about Africa. We talked about the world. There are 2.5 billion people that are employed in the food industry. So let's talk about authentication. Do you care where your food comes from? More importantly, do you care about how the people who fed you, who are responsible for getting that food to you, are treated? Because if we care enough, we sure aren't showing it. Because 60% of the people who feed us are starving. And I heard another statistic that when a farmer, a smallhold farmer, gets sick, they generally drop deep into poverty and die in Africa. So these brands are all protected, right? There are about 10 major food companies that control the world's food, and they're asking us in each one of these brands and all their advertising to trust them. You know what's going to happen? Is when you're representing these brands, when the consumers are getting more and more knowledgeable about this, here's what's going to happen. There's going to be a QR code on every one of those boxes. And it's going to show, and we already see some of this, like with Starbucks and ethical coffee and things like that, but you're going to see where it came from. You're going to see the source of the product. You might see the person. And you know what's most important? You're going to see the price. You're going to see the value. You can even see the entire value chain along the way of these products that we consume every single day. Food, clothing, these kinds of things. Why don't we see that now? Because, and why is there poverty and hunger in the world? I'll tell you. 69% of the food goes to waste. It's rotting in warehouses. How do you think they set market prices? And that gets us back to game theory, doesn't it? Transparency. If I have transparency of price, then the market truly sets the value, not the middleman. So I think as branding people, as business people, we need to start thinking about this. Because like it or not, this underlying model of what's happening with everything from our food to our clothing to our ideas is going to be recorded. And as that recording comes along and it creates data, we now see this evolution called artificial intelligence. So, artificial intelligence feeds on data. It consumes data. That's the lifeblood of artificial intelligence. So if we're creating the data, if you guys are writing documents, if we're passing those documents around, if we're putting them all in a database somewhere, then what we're doing is we're creating a way for these three things to happen: machine learning, natural language processing, and robotics. And I've met some of these guys. And they're not really very personable. That guy wouldn't even talk to me. But what I want you to think about now is all of those documents that you guys do, all those emails you do send, because emails are, in fact, data. All the things you do to communicate are data. And today, our data is growing at such an astronomical rate that without artificial intelligence, we couldn't possibly ever use it anyway. It's just a junk pile. So artificial intelligence is kind of like the marker of how we start aggregating this into something useful. It's not a brain, and it doesn't have a personality, and it doesn't do what people do, but it will definitely give us the ability to analyze what the data is telling us. 163 zettabytes, which is 1 trillion gigabytes, will be created in data by 2025. That's not very far from here, is it? How many people have enough staff to figure out what's going on? Even the billions of people that we have coming into the workforce aren't going to want to do that work, are they? So what's likely to happen, and what we're really going to see, is what I call HITs. Human integrated technology solutions. The humans create the data. We create the ideas. We need to own the ideas. We need to catalog the ownership of the ideas. We need to transfer value. We need to do a lot of things to make this technology valuable and create these hits. I'm wearing a smartwatch. Just out of curiosity, how many people are wearing a smartwatch? Okay? And that's technology. And it just beeped at me, so it just sent something up there, and somebody up there captured that data, and they really don't care what I'm doing right now, but a machine could. And that's how we're going to build new healthcare systems. That's how we're going to build new integration. I could have just gotten a payment. Or I could have told my 86-year-old mother, or a machine could have told her, it's time to take the red pill, Mom. Right? And aren't all those great ideas? Somebody's got them, and they happen all over the world all the time. So we're going to be catalogers of those ideas, tying it into this intellectual property machine. So human input and experience design and the growth of technology are interrelated. And that's really, truly what we have to do when we're embedding this. I don't think that there will ever be a way to protect intellectual property or data or contracts that in the future is legitimate by the way it's done today without tying it to technology. I don't think it can be done. So what we need to know is that nearly half of the jobs in the world today are vulnerable to automation. But I asked you earlier, what will your job look like in 17 years from now, 2035? Some of us might be retired. I hope I am. Some of us might be working, have built our organizations, what have you. But what will be done that is a manual, tedious process now that a computer could do? Freeing us up to do what? Have more ideas. Create more. And that's what we're really about, isn't it? So the issues that need to be developed when you're thinking about these protocols, as you work forward every single day in your careers, think about this. Privacy, security, the ethics of that. How are we dealing with the ethics, and how are we embedding the technology for those ethics into the work that we do? And the integrity of that work, and will it hold up? And finally, what is the ultimate outcome that we're trying to achieve? Because everybody who has an idea believes that it will somehow make some kind of impact. So if we start with the end in mind, then maybe we can start writing smarter protocols, and we can avoid the problem of creating artificial intelligence instead of artificial ignorance. And that's what I discussed with Prime Minister Trudeau, is how will we set a blanket stage, a fabric of reliable data so that we know that the medical advice that we're getting, or next week, the cannabis that's being distributed, isn't going to a 12-year-old. How do we know? Isn't it the same thing? Like, in the end, isn't this all the same thing? Isn't it all authentication, access, and protocol? And then truth in the data? That's the fabric of blockchain. That's really what it's about. And that's why I say the web wakes up. All these dead data, all these documents you create, all the things we do are important. They will teach the machines. They will establish the data. They will establish the protocol. Your professionals, you'll be authenticated. We'll know it's somebody that has the knowledge to feed the knowledge into the system in the first place. You guys went to school for a long time to get those credentials. Use them. Get them embedded into this. Let's create that future. Let's create a better machine. Let's use those blockchain protocols. Let's understand these distributed data networks, and let's use artificial intelligence in a way that's smart. And I call that the flow continuum. And you can look at the stack, the technology protocol, the organization of data, the data integrity, privacy control, the operation of systems, the collaboration of those systems, the tracking of the processes and the applications, and that is trust, truth, and transparency. And it's built on those four foundational pillars: blockchain, networks, applications, and AI. That's distributed technology in one image. So the questions that you need to walk away with are this. When ideas become broadly distributed as property rights, what will that look like in your profession? Broadly distributed, think about that. You can now take all this stuff you do and distribute it. Wow, what a client service that is, to help distribute those ideas and get them out there. Because now research can be marked. Yes, that was my idea. There's this huge fear in academia, especially. My son just earned his PhD, and we talk about this a lot, and we talk about the theft of ideas within academia. You know, the revisionist history that happens within academia. Sayers' Law, the reason the politics and academics are so high is because there's so little to lose, right? So the idea being that what is going to happen when these ideas become broadly distributed property rights, we can see in that genesis block of that idea that that's where it emanated from. Doesn't that create some trust? It creates trust. I'm not afraid anymore to collaborate. And once we do that, how is that going to affect our global economic models? How is that going to change our value proposition? How's that going to change the way money flows? What's this proof of stake, proof of authority, the proof of economy? That's when I call it trustonomics. That's what I'm talking about. It's going to change things. The distribution of knowledge doesn't mean it won't ever consolidate. Sure it will. But you got to stay on top of your game, and it's going to flow differently. And as on IP professionals, what will you do next? So I love this one to wrap up with Alan Turing when he says, we can only see a short distance ahead, but I hope that I've shown you there's plenty that needs to be done. And what I'm going to challenge you to is to think beyond your daily norm. When you get back to your offices, I'm going to challenge you to go look at what you need to do, and as soon as you pull out that phone and you start answering all those daily messages, remember, you're creating data. You're creating data in the world. Your mind is participating, and what I want you to do is, just like the t-shirt says, own it, because the future is yours, and it's all of ours, and we rely on it. Thank you. I can answer questions.
I don't even know where to start. I've been blown away, challenged on so many issues. This is fantastic. Are there any questions for Tim? If you could just use the mic just so they could hear on the
Absolutely.
Live stream.
Good morning, Tim.
Morning.
I'm Hadi Aldouani of the Montreal office of Bureau Joseph. First of all, thank you very much for this thought-provoking talk.
I hope that was you and not me.
We'll never know. I want to just go back to blockchains and ask you somewhat of a general. It's a multi-level question.
Okay.
What you just explained is that blockchain is based on trust, truth, and transparency.
Yes.
Now, correct me if I'm wrong. It's basically a system that produces a puzzle that data miners have to solve in order to gain this trust, correct?
Well, it produces a puzzle, and it produces a string of hashes. And we're going to talk a little bit more about how it works in the panel discussion. But the hashes themselves are immutable because they're sequential, right? So yes, but when we say the miners have to solve them, what's happening is as this mathematical model is being assembled, any compute can create that solution, right? So if I run an actual transaction, all these, right now what miners are doing is they're running mathematical transactions. But when we take all that compute power and we put it into these devices here, and we run a transaction that goes into the algorithm that creates that next string or that next hash, and it has an authenticated block based on the protocol, we now have the next hash in the sequence. So that's when I say it's trust, truth, and transparency. And we don't actually need miners. Now, we can have weightings of stake or authority in the model, which means that if I'm a non-authenticated user trying to create that hash, that has a lot less authority than if I'm an authenticated user, say a lawyer with a license that is from your firm, and it drills all the way down to, and this is the data that's gone into that hash. Okay, so yes, it's complicated. It's complicated by the fact that as we run these transactions, they become permutations and they become more and more difficult to run. And that's why we're going to have to solve this problem of consolidation. That's why they take so many machines to now solve a Bitcoin, because of the permutation. But once we distribute that out and we start going cross-chain and so forth, just like what happened with the internet, it gets faster. And that's what will likely happen with that.
Okay. So my real question now is about the stability of the system. If a miner gets so quick at solving these puzzles that he outpaces the process, basically, wouldn't that put the whole system into question, the stability of it?
You won't have miners. That's the whole point, is miners will not be controlling the system anymore. The problem with the blockchain, and the reason we created block certs as a proof of stake and proof of authority model, is because the miner themselves does control the system. So what you've seen is this distributed network that goes back to the old business model of trying to consolidate and build power and centralize the authority of the chain. But once we distribute that, and we distribute that power into everybody can become a miner, so to speak, and create these hashes, we now don't have that problem of integrity anymore or control.
Okay. I guess we'll continue this in the panel discussion.
Yes.
Thank you.
Thank you so much, Tim. We really appreciate you coming today, and we look forward to continuing the discussion at the panel. So thank you so much.
Thank you.
Hello, everyone. I want to welcome everybody to Emerging Tech 101. Actually, is that the clicker? I would actually like to have the clicker, please. Since it's a tech talk, we should have the clicker. Great. Okay. I just want to thank Tim for his amazing keynote. That was incredible before the break. I think everybody has a lot to think about now. And I think it's a great kickoff for our conference here. Next Gen IP, I think we're off to a great start. We're in such a beautiful environment to be meeting, so many things to be grateful for. The topic we're going to talk about today is Emerging Tech 101, and essentially we're going to be seeing a lot of things and talking about a lot of things that we're coming across in our practice. Our clients are asking us questions. You know, we're trying to digest and make sense of all the changes that are happening, and I think it's really amazing to have 3 people from different perspectives helping us with that journey. So, you know, we're really hoping to demystify some of these concepts. I think we got a lot of illumination from Tim's keynote, but I think we're going to get more as we go here. So I just wanted to say, you know, quickly about myself. I'm Izzy Calder. I'm a partner at Breskin & Parr in our Toronto office. And my practice is on the electrical computer patent side. And I'm also the co-leader of our firm's artificial intelligence group. So emerging tech gets me up in the morning, and I live for it. It's so interesting. It also keeps me up late at night a bit, too. I don't know if you guys are having dreams about those Boston Dynamic robots, but I am. And it can be quite, it's cool stuff, but it's also a bit creepy. But I'm going to be the moderator today, and we've got an amazing panel. You've already heard from Tim. I've just got their info here and some great pictures. Tim with a bit more hair, longer, lion looking. So you've heard from Tim, founder and CEO of BlockCerts and Fineos, who will talk a bit more about smart contracts and make it a bit more practical for us. We also have Robin Monks from FinAI. He's going to talk about conversational AI, which is a really interesting concept. And it starts to get into, you know, what it means to learn as a human. Jeff Betts from BC Healthcare, IBM, he's going to speak to us about AI in healthcare. So you've got these really interesting perspectives. Before we start, there are a few housekeeping notes. First, each of the speakers have a really tight 15 minutes to run through the material. I actually have brought this as a prop, which I'm going to use to make sure that we stay on track. This is the wing. For those who don't know, I actually got this in the airport, had a 2-hour delay out of Toronto, and this was very handy. This is the wing book club. And this will be used to signal, I'll just casually start to read a little bit of it, to signal that we're going over the 15 minutes. And if we can do that, then we'll have a nice 10-minute panel discussion at the end, and we invite questions from the audience as well as the folks that are live streaming. So please, weigh in with your questions then. Finally, as I mentioned, this is being live streamed, and so a warm hello to those who are participating remotely. Now over to our first speaker, Tim Vasko. As Paul mentioned, Tim is a founder and CEO of BlockCerts and Fineos and provides a patented blockchain platform for fintech, medtech, real estate, and lending transactions. Tim is a true internet and cloud computer pioneer, and he's bringing smart contracts into being. It's actually happening, which is very exciting. Fun fact, I have a fun fact for all the speakers. He has 5 children. So I think that they pay good attention.
4 of them are girls.
And 4 of them are girls?
Yes. So
interesting. Good.
Keeps me busy.
Yes. Good. So without further ado, over to the talking stick, yes.
Well, thank you very much. It's, again, wonderful to be here. So BlockCerts was created to solve a lot of problems that we saw out in the world of blockchain, and then to leverage about the 1.7 million man-hours we put into the technology learning from many transactions and across industries. And we call it the authenticated handshake. Now, the idea of a smart contract is really what I'm going to talk about and what it means. Earlier I spoke about identity. There are global laws out there right now for KYC, know your customer, and so forth. And that's fine, that gets started. But when we carry that identity markers, as we already talked about, identity theft, those kinds of things happen. So this blockchain smart contract, and the very first smart contract embedded in our blockchain, is the idea of creating the protocol, if you will, or the requirements of what it takes to get authenticated. Most of those protocols are out there already. They exist. There are rules, but humans are dealing with it, and the data is centralized. So what we're trying to do is trying to create a private key, which is a cryptographic algorithmic hash that only that individual has. Now, that private key can be recovered when it has multiple tiers to it. And these tiers will get more complex. Right now there are 3, a passphrase and the public key. The public key is what's identified on the chain. The public key is effectively, as I said, your microgenesis block, if you will. Now, it's hard to see, but on that screenshot down below, what you're looking at are transaction hashes. And a transaction hash means that as we're going through the process of creating a contract, we're creating these elements of data that we want to make sure get marked to the document. We'll talk about that in a minute. But the reason that this becomes so important or so impactful is because when we look at all of these epidemics of data breaches and so forth, what we're going to need to do is create this electronic signature, if you will, the way that we get in there. So the idea being that the more hashes we have, the more authenticated we are, right? And it's true not only for people, but for assets as well. So if you think about the volume of an asset that's being passed around, maybe this is, I'll pick something like a song or a picture or even a circuit, some of the things that you guys write in to protect, that's going to have its own authentication. And once we have that, we're starting to create a signature so things like 1 million fake bank accounts can't get created, right? The blockchain allows us to do that. Now, the way it actually works is what makes it pretty interesting. What we're doing is we're actually taking these data silos that we've created. And think of the data silos we have today as a rotary phone. And a lot of you may remember rotary phones, but I do. But, you put your finger in, you're ringing around, da-da-da-da, and some of those worst phone numbers like 10000, right? And so the idea being that these data silos don't talk to each other, they're separated, they're not able to be interactive, and that has been how we built our business models. So software fees, bank loans, vendor credit, working capital, equity funding, all those kinds of things revolve around centralized control. The way we solve that problem is on these different layers. So the first layer is the user interface layer. That's the transparency. That's the app that you get on your phone. It's the software you have on your desktop. It's the software as a service models. So when you're writing contracts now, what you'll be doing is saying, at this particular inflection point, when you're protecting IP, I think you'll be saying at this particular inflection point, I want to hash that to the blockchain. I want to create a true living document of what I'm doing. And then that will hit through these web service layers into two areas, and this is really important. We have massive compute power in the way we create data today, and that won't go away. Relational databases won't go away. In fact, they're about 6,000 more times efficient than the blockchain database. So they're faster, they're getting better, they will get more flattened, and the AI guys are going to talk to you a lot about that kind of stuff, so I won't bother. But that's kind of this layer of compute that's going to get better, faster, stronger. But what we can do as that compute gets better, faster, stronger is we can start protecting and moving that contract through this concept of code called the smart contract into that blockchain layer. And that's where all your hashes are created. So now what happens is, let's say I'm out here on my user interface, and a user interface tool can be anything. It can be a word processor, and I'm typing in there, and then all of a sudden I say, I want to turn this into a contract, or I want to get a signature, or I want to just simply document that everything that happens in this particular area is going to have an action. Well, it's going to call a web service, and it's going to push that into your core database. Remember, you've got a private key, so you're still on the first three, you're still in the human readable world here, right? You can see it. And you've got access because you've got the private key, and that key's been authenticated. And I now push that, and I go into the cryptographic world, or I hash it, and I record it. And that's effectively the way the blockchain works. So you're going to have these, you're using these layers, although the majority of the time you won't have any idea of how this works. And the thing that I always like to point out to people is You probably don't know how Netflix works, but you probably watch movies. So it's the same thing. So what we're doing is we're taking this device, no matter where that device exists, and we're using, you probably have heard about coins and tokens. So a coin is actually a transfer of value. It's just this Bitcoin is worth this much money on the market today. It's a speculation device. But a utility token is actually a piece of software. And the more sophisticated that software gets, we call ours the Be Certain token, or the Be Cert token, and our app is Be Certain. And basically what it does is it carries all of that software, all that functionality in one token, right? So what you're going to do, instead of going through silos of tools, the SaaS tools you use every day, you're going to go to one tool and choose what application, we call them gadgets, which gadget you function you're going to need within that contract that you write. So it'll get more and more sophisticated, drag and drop, more services will be there, and think of it like the App Store. But what it is it's the D-App Store, or the distributed application. And the real kind of transformation is you won't be paying a seat fee anymore. You don't need to pay a seat fee. There's no central authority to pay a seat fee to. What you'll actually be doing is pushing these hashes, and those hashes will have a compute cost, or maybe a legal cost, a services cost to it, something like that. And so in the Be Cert token, we call that cost Inc. And you guys should all appreciate that, because the more the ink, the more the cost. And the ink is 5 decimal places, and then it goes down to further decimal places called pics. And if you can think about a laser printer or something like that, the more ink you use, the more pics are used, the more colorful it is, and so forth. And that's how a token works. So a utility token is vastly, vastly different than a cryptocurrency, which is what the market started with. It's actually a piece of software. So that software is going to go from your business document. It's going to marker all those customer identity flows. It's going to go through these phases. And these are kind of the things on the left-hand side that it will start helping solve. So sources and end users and connected assets and supply chains and IP licenses and all of that stuff is going to get a life to it. It's going to move forward. So that's what it's going to look like as they build. And you can imagine now that compute power that I was asked about earlier gets bigger and bigger and bigger on that blockchain, which is why it's important to combine these technologies, especially these things like AI. The infrastructure looks like this, and I've got the book, so I'm going to pass this along and say thank you, but I'm happy to answer any further technical questions.
Great. It's more of a wrap it up. This is more of a wrap it up as opposed to just stop dead, just so you know. Not to worry, not to worry. But thank you, Tim. That was amazing. Okay. Oh, I'm sorry. Fear is one of those things we're trying to get rid of. Okay, our second speaker is Robin Monks. He's the Director of Engineering and Interim CTO at FinAI. FinAI uses conversational AI to deepen relationships with banking customers. I love this from Twitter. He's been designing and building big things for over 15 years, and he's worked on many aspects of the software development process. So he is a techie underneath that suit.
I'm hiding very well today.
You are. So Robin previously co-founded something pretty interesting called Hotspot Parking. It's a mobile payment app, and it expanded to 8 Canadian cities under your watch, which is pretty cool. You thrive on making tech accessible and useful to progress humanity. So Robin has quite a philosophical view on things, I have to say, from our conversations. So Robin's fun fact is that it's his birthday today. Well, okay, but we don't have time to say happy birthday or prank him, so that's going to have to happen at the office later. So take it away.
All right, so let's get started here. So I was going to talk a bit about conversational AI, kind of what we do. I'm going to describe a bit of the problem that we're trying to solve, and then I'm going to talk about the solution. So by the time we're done, you should know the problem pretty well, and then our approach to solving it. So just to kind of give some quick FinAI at a glance, some points here. So our vision is to improve the financial well-being of 100 million customers by 2025. We work here in the city. We are located at Homer and Nelson down in Yaletown. We're a team of 50-plus people working on this problem. Finn is still a relatively new company. We're like 3 or 4 years old now, so it's still relatively new. We're still continuing to improve the technology, and we've already won a bunch of awards for the technology we're creating. So the thing to call out on this slide is really just the 100 million customers to improve their financial well-being. Why do we want to do that? Let me explain the problem to you for a bit. So 57% of Americans are financially illiterate. That means they don't know how to do compounding interest. They don't understand the basics of how to deal with their financial life. And even beyond that, 21% of Americans don't even have a savings account, which, when you think about it from our perspective, we sit in a bit of a high tower, but imagine having no buffer and no understanding of how to build one. Yeah, and 60% of global consumers think banks should help achieve those goals, but only 26% of people actually trust a bank. And compounding all of that, there's $1.4 trillion of student debt in the U.S. So it's a huge problem. 72% of people feel stressed about money, at least some of the time every month. We have 12% of people who are extremely stressed about money. These are people that are literally, it's affecting their medical health because of the deal dealing with money, and they're not able to figure out how to manage their finances. And 22%, this is especially as a Canadian, this is the part that really disturbs me. These are U.S. figures. 22% of people have skipped doctor's appointments and skipped health care because they don't have the finances to deal with that problem. And you might think, well, we'll solve this with education. Like, education will eventually solve this problem. People will get taught. It will go away. But the problem is 80% of people are learning about financial literacy through their parents. And if their parents are financially literate, they're going to be financially illiterate. So it's a compounding problem. So this is the problem. Everyone understand the problem? If you want to just say like a collective sigh of like, yeah, it's kind of depressing. But let me now share the solution. So the opportunity is AI. AI is a multi-trillion-dollar kind of wave going through technology right now. And FinAI is targeting all these people and trying to bring financial literacy to them. So our solution is a conversational AI assistant powered by natural language processing, or NLP. The goal is to bring financial agency to people. The goal is not to automatically sell their finances. The goal is not to just give them details and like prevent things from going wrong. The goal is to teach them how to manage their finances so they have agency in their own lives and how to manage their finances. These are the 10 life journeys that we're focusing on. We basically decided we wanted to narrow this focus down. We can't boil the ocean. What are 10 things that we can give people the support for? They can be more successful at life, and we can start to turn this whole boat around, really. First job, first credit card, student loan, first car, planning to get ahead, saving for the first home, the whole list is up there. We're going to be able to provide support at each one of these junctures, and we already are providing support in the market with some of our partners for many of these junctures today. So the goal is that in the future, no one will ever have to go through these processes without having the support they need and the knowledge they need to make the right decision. So we're going to start turning around people's ability to manage their own financial health and well-being. This exists today. So let me show you some examples. This is Time Digital. They are a bank that's launching shortly in South Africa. And this is an example of a coach. And this coach is designed to solve the problem in South Africa of basically an almost universal poor credit score. People generally don't understand how credit scores work. They don't know how to improve it. So we built this technology in partnership with Time to educate people on how to manage their credit score, what it is, what it does, how to improve it, and to guide them step by step through that process. Another great example, you might have heard of this company. It's called BMO. We built a system for BMO called BMO Bolt, and right now it can solve a few basic situations, but one of the more complicated ones is mortgages. It can go through and walk you through the process. It can give you details of what it means, what the effects are, give you some advanced information around what you should be thinking about as you're planning a mortgage. And then if you decide you want a mortgage, you can say, hey, by the way, you're already here. Do you want to go and talk to a mortgage specialist? And it can give details to that specialist on your situation to help you make an informed choice and decision. So it's better for BMO because they have more detail. They know how to serve you better. It's also better for you because you have information before you make a potentially bad choice. Visa, another company you've probably heard of. So we were working with Visa in Canada to work on technology that allows people to manage their credit card. One of the cool use cases we're working with them on is who here's lost a credit card at some point in their lives? Everyone, yeah. Who was immediately found the next day and was like, oh shit, I didn't have to call it, it's missing. So, like, yeah, 55% of lost cards are found in 48 hours. So our use case with Visa is you can actually connect with Visa through a chatbot and say, hey, I lost my credit card. It can then call the last place you visited using an AI system and ask the person that picks up the phone if your credit card is there. If they say yes, it'll say, can you hold on to that? Mr. Smith will be in shortly with his ID to claim the card. And the entire period while it's being claimed, your card is frozen so no one can use it until you go and pick it up. And you tell Visa, hey, I got my card. And your card is unlocked and you're ready to go. So that's what we're building with Visa right now. Someone's really excited for that. And it's cool. I enjoy it. Like, I love talking about tech. ATB is another example here in Canada. The last one I'll share with you for examples. ATB was the first full-service chatbot for financial banking in the world. I was actually teasing my IBM colleague that we beat Watson to market. So this launched in Alberta, so a smaller bank. You can go there, and if you're an ATB customer, do all of your financial work using a chatbot. You can say, pay a bill. You can say, what's my balance? You can say, how much should I spend at Starbucks next month? They can guide you through all these steps and processes with real, actual transactions and verification. We've been using this successfully in Alberta for almost a year now. I'm working on launching a new version with them shortly that has even more functionality. So backing out a bit, how do banks actually customize the experience? Our belief is the next couple of years, every bank will have to have some sort of conversational AI platform to serve their customers. So how can they stand out? How can they differentiate themselves? If every bank has this, how do they make it different? How do they protect what they have? The first aspect of that, some of what I've been showing you just now, has been custom brands and styles. Those are things you can already protect pretty easily. Other ways you can protect it are a personalized customer experience. So that means you have custom products with your bank. Being able to patch those to your customers correctly is incredibly important. Use cases we're working on with ATB is suggesting different account types if you can make a better use of an account type. So rather than being charged an account fee, it can tell you, hey, you can move this other account that will serve you better. And it can guide you through those choices, and it can make personalized decisions for you. It can also use a treasure trove of data the bank collects on you to be able to give you actual advice and feedback on that data. So you're actually getting value from your own data. And it can suggest things about habit patterns. It can say, hey, you're paying for both Google Play Music and you're paying for another example, Spotify. Do you want to cancel one of those services? It can guide you that process. So it can actually help you make better decisions. And we work with our partners to figure out how they want to enable this customizability in their platform. Another great way is to make banking more human, which just seems odd, right? You're using AI and you're saying you're going to make the bank more human with AI. How does that work? That seems weird. But the fact is, the AI assistant knows you, can follow you around for years. And this entire time, you're able to build a relationship with the system. And it's able to say and start to pick up on your habits and patterns. It can remind you of things if you're forgetful. It can give you additional feedback and knowledge, and it can help you go through different stages of your life. Those 10 stages we walk through, our goal is to have the same assistant help you through all 10. So as you're going through these stages, it can help you step by step along the way. So you're actually getting better with all these things, and you're able to develop a relationship with the bank because the bank has helped you get your student loan. The bank has helped you with your first car. The bank helped you understand how mortgages work. And all this stuff are things you're developing a relationship for. So really being able to have a better relationship with your financial institution and be able to trust a bit more is one of the things we're offering to our partners. And this might be my last slide. Yes, it is. So thank you so much for your time. It was really great chatting with you guys.
Awesome.
I didn't even get the book.
I know you didn't get the book. I should have brought extra copies to hand out. Okay, thank you, Robin. That was great. It's really interesting to get sort of a feel for it and to start to feel some of those connection moments you would have if they say, hey, your kids have signed up for a whole bunch of apps they're not using or they did not use them for the past 3 months. Here is how to get rid of them. Maybe present you with the screen. So our last speaker will be Jeff Betts. He heads up BizDev at IBM's healthcare practice in BC. He's got over 30 years of management and project leadership, 20 of them with IBM. Fun fact for Jeff, it was IBM's Watson question answer tech on the game show Jeopardy in 2011 that inspired you to start adapting AI for healthcare for Canadians, to improve healthcare for Canadians. But I actually think the fun fact is that he's wearing a fish shirt today because he would much rather be fishing generally. Is that true?
Thank you so much. Some might think I'd rather be fishing, but I have an opportunity to talk about two things that really excite me. The first is healthcare. I've been in the business of healthcare for about 20 years now from an information technology point of view. And the second is about AI and how those two things come together and what they mean for us as people, as patients, as family members, as voters. Healthcare is a pretty big tent from a social issue perspective. Over in the lower right-hand corner there, you see IBM Watson Health. Watson was the name of the gizmo that we first exercised against Jeopardy in 2011, kind of bringing AI onto the public stage, although a long-standing discipline within computer science for decades. IBM published its first paper on natural language processing in 1957, the year I was born. So, from the point of view of the problem in healthcare, this is a really critical diagram. If you can get your head around this, then I won't have to explain why we need AI. I won't have to explain the benefits to you. Because in healthcare, as in many other industries, but healthcare is a special case, we're facing an exponential explosion of data. And well beyond the capacity of human cognition to absorb. We send doctors to school for 12 years, and as soon as they come out of school, they're obsolete, and there's no way for them to keep up in their own domain. Dozens of papers are published each day, right? So, other technologies like medical imaging, as these modalities become better and better, the exponential growth in data is really creating massive challenges for radiologists and their ability to find signal in that noise. So these are some of the examples of why this exponential curve requires something different. And when you look at the grand kind of spread of healthcare issues, data explosion, medical data doubling every 73 days, right? I think that's a critical number. But we face problems with the number of physicians and physician burnout, the number of nurses, right? Many of those caregivers are aging out. We're not replacing them as fast enough. Medical images, I just mentioned. Chronic diseases, right? The older we get, we're getting really good at keeping Canadians alive longer. Well, the older we get, the more chronic conditions we have, which add layers and layers of complexity and cost onto healthcare. So it's not hard to see why healthcare is consuming half of provincial budgets in British Columbia. Now, there's insatiable infinite demand and constrained taxpayer supply. So, it requires us to, I'll just skip over that one, to do something different. And AI has a lot of promise from my perspective. IBM divides the domain into two sides, right? Knowledge-driven method and data-driven method. From knowledge, you as lawyers would understand the concept of a corpus or the written law. In medicine, all the published journals, all the textbooks about disease, all the categorized knowledge about things, scientific papers. And on the data side, facts about me as an individual, my blood pressure, right? My genome, my proteome, right? Those are parts of the exponential explosion medical data. And so how do we find insights? How do we find the needles in this massive haystack of both knowledge and data that's being brought into clinical care? In general, IBM looks at healthcare, our healthcare business as really an analytics business. And I mentioned that we've been working on AI along with many, many others for a long, long time. This is kind of a hierarchy of focus. We talk about machine learning. There's something more focused than that, deep learning. Anyways, there is this kind of progression of different techniques and methods that we're starting to explore in healthcare. So IBM often uses the word cognitive computing instead of AI. Because that's who we are. We like to give things names that we like. But it's understanding, the ability of machines to read and to remember what they read is a profound shift. In your business, you deal in the world of text. I grew up in government. I spent quite a bit of time in the public sector before I came into information technology, and it's a world of policies and procedures and paper. And you can see the impact that it's starting to have in these domains. The ability to reason over what it's read, understand the relationships between concepts. Most importantly, the ability to get better at this process of reading and reasoning and understanding, the ability to learn and improve iteratively like that. And of course, none of this is worthwhile unless you can integrate it into the workflow of the human being that's actually being augmented by it. And this is a huge problem in healthcare. Workflow and the process of workflow is a very personal thing to physicians, nurses, clinicians, and how a big part of what we do is trying to figure out how to easily support them with these tools in a way that doesn't distract. So I like this slide a lot. We talk about augmented intelligence as the meaning of AI. And I think it's really valuable because AI isn't there to replace us. Robots, I don't believe, will take over the world. Hopefully not in my day. Except your financial one, I need that one. I'm pretty...
That part of your life you want me to know.
There, I do. Yeah. I could use some real help there. But you can see that all the things that we're good at, that humans are fabulous at, the creative power, right? Imagination, abstraction, the ability to generalize, the notion of compassion, very critical in healthcare. And the things that AI is fabulous at is, consuming millions and millions and millions of pages and understanding the meaning of everything in there, creating a stochastic model to identify the relevant elements of a problem inside a massive corpus and comparing it with a huge amount of data. Reducing bias is an interesting one. There's a lot of stuff in the press now about bias in AI, and we can talk about that in the question period. But compared to the bias of humans, I'm really happy about the bias in AI and our ability to be transparent about it, to actually push it out into the daylight. So we know how the systems were trained. We can identify bias early and attack that. But I think we have much more hope in attacking bias in all domains through augmented intelligence. So some examples of how these things are starting to come down to roost in healthcare. The Mayo Clinic, a longtime customer of IBM, one you may have heard of. A lot of my examples are in the area of oncology because oncology is one of the first areas that IBM chose to focus on when we started Watson Health, the division of Watson Health, for a couple of reasons. One is the velocity of new knowledge is very, very high in oncology. The number of clinical trials, the new facts, new understanding of the molecular mechanisms, new understanding of disease process coming out quickly. And also the massive amount of data that we're now starting to collect. Cancer is a molecular disease. And in my lifetime, I know that if we're diagnosed with cancer, the first thing they're going to do is do a whole genome sequence of that individual. That will become clinical standard of care very quickly. And then you can compare the progress of tumors against that whole genome sequence over time because the cancer is mutating all the time. It's always moving. And so the only way to get on top of it is to look at the molecular level for individuals. And that's what a lot of the stuff is coming towards here. So clinical trials, because oncology is experimental, right? You talk to oncologists, they say, well, it's really an educated guessing game. The oncologists I talk to admit that freely. Clinical trials, experimenting, finding out which things are going to work on this patient is a critical step. So technology being harnessed by Mayo to get more people into clinical trials. Again, here's another example around oncology, but at the community level. You know, the Mayo is this great global marquee in medicine. Well, a lot of medicine happens out in the community in smaller organizations, and clinical trials being able to bring clinical trials offering to people in the hinterland gives hope. It's a very important step in the process. In the third world, One of the great promises of AI is that it amplifies expertise. This is critical. In India, where Manipal hospitals operate, there's 1/100th the ratio of oncologists to patients as there is here. And so if you can use augmented intelligence to give a GP kind of standard of practice levels for a general practice oncologist, then you're able to bring treatment to many, many more people quickly, faster, easier. We're seeing this China, South Korea, those jurisdictions are really taking this technology up very quickly and integrating it. New York Genome Center, I mentioned that oncology is a molecular disease. We've done similar work here at the BC Cancer Agency, where I mentioned biopsies are sequenced, the tumor is sequenced to understand its mutations. We take those mutation facts to the corpus of knowledge, look in every article that's been published in the last 20, 30 years in oncology, and see which drugs are working on these mutations and help narrow down and bring out ideas for oncologists they may not have assumed. There's many counterintuitive treatment options in oncology once you get to the molecular level. So using AI to help oncologists very quickly develop a list of potential treatments to try that may be different than the ones they normally assume is a powerful thing. Here's one at servicing more treatment options than oncologists would normally do. 33% of patients in this study with University of North Carolina, although we had 99% concordance between Watson for oncology and the tumor board, the humans that look there, Watson for oncology was able to suggest 33% of patients with new treatments that the tumor board didn't. Right? So again, adding hope, again, adding options for oncologists is there. The notion of looking in the white space in knowledge for new knowledge. This is what Barrow Neurological Institute is doing. They're trying to understand the molecular basis for ALS. And using Watson for drug discovery, we're able to very rapidly put together a new set of targets for their basic research on the molecular processes inside the disease by using it to connect domains of knowledge that normally aren't in the same place in researchers' heads. They could be in chemistry, right? It could be off in other parts of science. And all these things are being exposed and shown to have correlation through this kind of tech. So, well, how do I go back? This is an important slide. IBM has a very long history of research. We have the world's largest privately held R&D organization, over 3,000 PhDs in 12 sites around the world. We throw off a lot of patents. I think there might be a slide on that at the end. But some of the interesting things that we're doing in research, the notion of computational psychiatry is a new emerging space in healthcare. Identifying patterns of schizophrenia. We did some research with investigators at the University of Alberta in Edmonton, looking at PET scans and the data in PET scans and using it to identify patterns of schizophrenia. We're seeing a bunch of other treatment areas amenable to computational psychiatry. That area I'm really excited about. But the promise in healthcare is prediction, right? Prediction that would allow you as a person to change your habits, to take an intervention on your own behaviors, or to help a physician make an early intervention that stops you from becoming one of the 1% that drives 80% of our healthcare costs, right? I think we'll talk about ethics around AI in the question period here, but from our perspective, AI is not to replace people, it's to augment, to give them power, to amplify their expertise, to save them time, to separate signal from noise more quickly for them to make better decisions. Transparency is a key issue. I talked about bias already. And skills. It's imperative that the systems that professionals use are trained by them, right? That the domain understanding that the system encapsulates comes from the people that are using it. That's some of our point of view about how the tools should be used. So our mission is about hope. I'm happy I get up, go to work every day with excitement because this is where medicine is going, and I'm happy to be part of it. I mentioned we have lots of patents. 107-year-old company for the last 25 years been the global leader in U.S. patent filings, often surpassing our competitors, the top 4 or 5 that don't file as many patents as IBM does. This is the reason why we're 107 years old, is we invest in basic and applied research, and it keeps us going. It makes us relevant for our customers. And many of our patent lawyers asked me to show this to you. So consider yourself shown. Thank you very much.
Great, thank you. I didn't get to use the book again, but I just want to show everybody because it's our wonderful book for our book club. So make sure you get a copy. So I guess, that was great. We've sort of had all these different perspectives, and I think that's been just so helpful for us as IP practitioners. Essentially, we're going to start our panel discussion and go through some issues that we talked about. We had some great organizing calls, actually, between the 4 of us, and we really spent time sort of talking about that Venn diagram of, intersection between blockchain and AI and IP, and I think there's just so many interesting issues at the borders there. So what we came up with was a few issue slides to sort of start the panel discussion. And I would encourage the people that are doing our live stream and participating remotely to also ask questions through the app, which I have right here. So if you ask a question, I promise I will try and get it in front of our panel. And also questions from everybody here in the room. We wanted to just start with this first slide, and I have a question really for Tim on this. We talked about applications of blockchain for intellectual property practitioners. And we've listed out some of the things that we talked about here. How can blockchain help us do our jobs better? My question for you really is, as legal practitioners, what are we really likely to be using over the next couple of years from the blockchain perspective?
Well, I think what you're going to need to be using is a model of writing contracts that can be converted into a data set. So it's really reaching beyond this concept of I'm writing this document or I'm bringing this form forward to I'm writing this document, but these are the inflection points as a legal practitioner of what I'm trying to achieve or what the goal of this document is. And at that point, it becomes a data field. It actually is going to be recorded, and you know that behind that there's going to be a piece of code that says, I really need to make an impact with this and hash it to the blockchain so that it's recorded. I also think that you're going to need to think about a broader spectrum of, well, from a client services standpoint, what is the client trying to achieve? And when they start to commercialize, what's that likely to look like out there in the world? Because I think that will make a big, big difference as to how you draft your documents. So not only will you be drafting in a way that you'll push that through an engine that says, okay, that's now going to be my template, if you will, or my smart contract for this kind of a purpose, whether it's proof of mark or creatorship, ownership, or what have you. But what's the commercialization of this likely to look like? And where is it going and so forth? And then obviously the last piece is the regulatory aspects, which you guys know a lot more about. But when we look at regulations and we look at jurisdictional regulations, real-time regulations, and things like that, that all becomes quite possible as you're drafting now. So whether it's enforcement of a license agreement or it's some compliance situation that needs to be handled, or in effect it's dealing with all this massive amount of data like the team here has been talking about in intellectual property, what is it that you're writing and how is that going to be affected when it gets out there, when it's actually put into use?
Mm-hmm. Okay. That's great. I've got sort of the next thing to talk about is Robin's point about user experience, which you demonstrated quite wonderfully for us. So you've basically said it's really important to your customers to really protect that user experience. And, on the slide here, we've just, some things we talked about, essentially things that you can do from an intellectual property point of view. But I was wondering, and again, this sort of speaks to Tim's comment, which is, what is the commercial instance of their idea? So, that is really at the core of what we're doing and how we can help our clients. But can you help us kind of pull apart what you mean by user experience?
Yeah, for sure. So when you are licensing a technology like AI, you want to have a layer on top of that you control, that you can protect, and that identifies you as a brand. User experience in this situation is really the technology that is then being adapted to your brand. So it's brand identity. It is characterization, because a lot of these banks, when they're working on this kind of technology, they develop a persona. So they have branding teams and marketing teams going and basically creating a character. So they're creating the character of this banking associate or affiliate that then is being broadcast to the entire organization as is how we communicate about our brand. And they do that with their bot as well. They're going through, they're creating content, they're setting tone. So we have some customers that want their chatbot to be friendly and chirpy and excited, and really excited to help you and kind of cool. They're going for like the early 20s crowd. And then there's also folks that really want the really standard, really almost terse, very, very to the fact, very to the point, trustable, dependable. Exactly. And they want to have that kind of experience. So they're setting the tone. They're creating this character. And they're creating these graphics, materials, and brand identity around it. And all that they can protect in various ways. So they are able to control that very closely. And then the other piece of this is data. They control a lot of this data. They have large data stores that a lot of times they don't know really what to do with. Just now we're starting to get into big data and getting into good uses of that information. But you can use that to provide good experience for your I was going to say user, but for your customer. Because you can say, look, based on your patterns, we see that you might be at risk for this, or you might be a better offer for this, or we can offer you this because we know you're a low risk. Those are things that they can do with their data, and those are other things that they can't easily be stolen from them as long as they're maintaining it correctly.
So to that point of the experience with the bot, Robin and I scheduled our first call using Amy,
yes,
which I thought was a person, and I responded to my usual sort of chirpy self saying, hey, thanks for helping us make this happen, and realized it was a bot.
I have a fully
which
digital
was a little
personal
bit soul-destroying,
assistant.
I have to say.
Yeah. It works. I had someone the other day actually email Amy and say, I'm so sorry I can't make my meeting tomorrow. I have the flu. And the AI responded back, I'm so sorry to hear about that. Can we reschedule that for next week when you're feeling better?
Right.
Right. That's the level of...
That's the level.
We're getting to now.
So my question is, can Amy sort of tell that I'm chirpy and respond chirpy, or maybe they can tell I'm grumpy and maybe respond with a slightly different... I mean, we're kind of, can the bot evolve to mirror?
So there is some interesting work being done on emotion and detecting emotion. Even Watson has a great amount of information now around the emotional weight on things.
Yeah, you can call it from an API. You could integrate it into your program.
We actually do. So we not with Watson, but a different company. Sorry. We do get feedback and see if people are angry when they respond, and then we categorize those responses as
number of exclamation marks. They can be angry or peppy, right?
Yeah,
how do you interpret those exclamation marks?
It's cool tech.
That is pretty cool. Okay, so over to our next slide, and I think this will be something that we can all weigh in on because it's pretty interesting, and there's some other issues behind this as well. Jeff, we've talked about adapting AI into healthcare. Of course, there are some big barriers. I just had tea with a physician friend of mine, and she was saying, there really aren't the incentives for her to go on and take all her data and put it into a system, into a smarter system for referrals or whatever else. And so I think we understand that there are some big barriers relating to data privacy and protection for patient data, and how can medical professionals and patients really be incentivized and convinced to trust the new tech solutions? I mean, how do you see that going? Because I think, as you say, there are a lot of impediments there. How will that play out?
Yeah, good question. Standing back from it, and my experience in healthcare and the public sector around privacy legislation and privacy policy in Canadian jurisdictions, often privacy is the dog that wags the governance tail, and in many ways has become a real gating factor on some areas of research, in the sense that while we're trying to protect privacy, we've really stopped a lot of innovation that could happen. We're struggling to find better models to use. I think in British Columbia, we're looking at revising the privacy legislation, some of the policies associated with it. So I'm hopeful that we'll find a better balance around that. From the point of view of protecting privacy, I'm a believer in information technology. I see in my doctor's office the amount of paper that's lying around there that has my medical history in it that's really unsecured. I know the technologies exist to make it easy to secure them much more tightly on information technology, and blockchain, quite frankly, holds immense promise in the healthcare space. One of the most exciting things about my job, I think, is some of the key use cases, just from basic electronic medical record keeping. Blockchain holds the promise of creating a truly personal health record that's controlled by me, that is secure, and that allows me to permission everybody at a very granular level about who can see what about me. And it gives the physicians a collaborative accuracy engine about me. That's because our healthcare data is spread over hell's half acre in so many different systems. And so through the federation of a blockchain, you could see it really giving power to individuals and giving confidence to physicians that they're using patients' information in the right way. Go ahead.
Do you have something to add on sort of the blockchain?
Yeah, well, that's kind of the idea, and Jeff's exactly right, is the idea of this private key. And we talk about this block. Well, that block is going to identify me. So we can now start saying, well, if I want my data to be out there, my personal health record to be out there, and I can time it. Like, I'm going to send it to this doctor, and not only that, I know I'm actually sending it to a doctor because they've authenticated through the system as well. They've got their ID was checked, their license was checked, and so forth. I know who's seeing it. I can see when they see it. I can permission it. If they don't get to it, I can re-permission it. So putting the control in the hands of the patient solves a huge amount of the privacy problems and gets the healthcare out there, and also incentivizes your friend to participate. So that's that collaborative trust idea. Yes. You know, if we're going to get faster analysis, like we just saw with one of the slides said 9,600 minutes for analysis versus 10 minutes for Watson. Right. Well, the doctors need that. So it makes their lives easier. That's the incentive. So it makes you smarter, and you're doing a better service for your patient.
So with trust, it'll grease the wheels.
That's right.
Essentially. Okay. Great. Now, I do have a question coming in from our live stream audience. It's I believe it for Tim. Can you share how a smart contract can automate a contract versus PDFs of today? So it's that kind of, what's that shift?
So a PDF today is actually created through data streams. The way that you look at your contract is just in the basic contract law, or the purpose of the contract and the terms in that contract. What have to come alive? If it's a contract that has a payment, well, what are the markers where that payment actually happens? So right now we depend on people to do that. Like, I shipped this product, or I delivered this service, you owe me money. Well, maybe I do, maybe I don't. But when we gather all that information, we have these markers that happen and start automating these elements within the terms of the contract. So the contract itself already says what's supposed to happen, but right now a PDF is static. Once we put those terms into an actionable piece of code, it happens automatically. And we can also start doing things like validating where there's balances for payments and so forth. So it goes on and on and on. But the fact is, a contract does tell you what's supposed to happen. That's a good contract to do that. And good participants in a contract will actually do that. The computer helps facilitate that process.
But there's the possibility of dynamic adaptation.
That's right.
So the intent of the parties being played out.
Yeah, so a smart contract, think of it as a wrapper. It's a tool for what you're trying to create, what you're actually trying to do. That's what it is. You just need the tool, and you put it in.
Right. Okay. I'm going to take a chance just to see if there are any questions here in the live audience. See any hands? I see coffee cups going up. Well, since we have a little bit of time left, I thought, maybe we could talk a little bit about the ethics of what we were talking about, the bias in AI. And I think you had a very inspirational, Jeff, concept of, with AI, we can make bias more apparent. And I know there was this ProPublica study on the use of software to predict recidivism, which is the chance that a criminal will recommit. And ProPublica reviewed it and found it was biased against black defendants used by judges and courts to determine sentencing. So, these things are out there in the news. There is bias in some of these prediction engines. I guess my question would be, how do we safeguard against that kind of thing? What's the solution? How do we get to that transparency?
I'm sure my colleagues will have some other suggestions, but actively IBM is including a bias detection engine in our cloud service, which will apply to anybody's models. Microsoft's, Google's, everybody's AI can run this module against it, which surfaces bias in the design of the algorithms and the execution of the algorithms. So you can use the tool to look at itself, right, and expose itself, expose its own behaviors.
Okay.
But it's important to understand. I think I'm not a statistician, but the data scientists tell me that machine learning really is statistical discrimination. It is pattern recognition. It's what it's designed to do.
Right.
So it really depends on how it's trained, how it's exercised, and so transparency is one of the elements that IBM put in its set of principles, and we've joined other vendors in the AI space, all the big names that you could think of, 2 years ago in September, formed an organization, a not-for-profit, to specifically focus on these areas and ensure that there's a light shone in this space.
Right. I'm going to have to get the book out for myself because we are going over time. I apologize, so we'll have to cut off here. But I want to say a big thank you to Tim, Robin, and Jeff for all the hard work that you did in preparing for this. I'm really impressed. And being with us today, I think the discussion's been really useful for us as practitioners. I also want to thank everybody who came today and participating on live stream as well to discuss this with us. So I hope everyone enjoys the rest of the conference and Vancouver. Thank you.